As the Earth moves around the Sun appears to drift slowly among the stars, the zodiac constellations, through the year. This great circle path the Sun follows is called the ecliptic because this is the eclipse plane on which the Moon has to be in order for an eclipse to occur. The ecliptic great circle is tilted by 23.5 degrees with respect to the celestial equator because the Earth's rotation axis is tilted by 23.5 degrees with respect to its orbit around the Sun. The two places where the great circle of the celestial equator and the great circle of the ecliptic intercept are the vernal, or spring, equinox on about March 21st, and the autumnal equinox on about September 21st. This picture also shows the solstice points where the Sun would be as far from the celestial equator as possible on June 21 and December 21. Notice how these dates are 3 months apart and all on the 21st day of the month. The actual date can be slightly different depending on your time zone and where you are in the 4-year leap year cycle. This last picture is an all-sky view of the Sun's path at the solstices and the equinoxes. Note that the Sun's path on other days of the year will be somewhere between the two solstice arcs. For us in the northern hemisphere, the June solstice daily path is the absolute highest the Sun gets, and the December solstice daily path is the absolute lowest the Sun gets. On the rest of the days of the year, it follows an arc that is in between the solstice extremes. In the spring and summer, the Sun is rising in the northeast and setting in the northwest, so the path is long and high. Conversely, in the fall and winter, the Sun is rising in the southeast and setting in the southwest, so the path is short and low. During fall and winter, the Sun is below, south of, the celestial equator, and during the spring and summer, the Sun is above, north of, the celestial equator. Next slide. The next several slides have animations of the Sun's daily path at the solstices and equinoxes from two different locations, Los Angeles and Fairbanks, Alaska, so you can see the effect of the latitude and the time of year. A side view of the Sun's motion on the celestial sphere for the equinox is on the left. The red dashed arc or circle is the celestial equator. The observer on a seemingly flat Earth would be in the very middle of the animation where the north-south lines and the east-west lines would intercept. On the right is a top view if you were looking from directly above the observer. On the equinox dates, approximately March 21 and September 21, the Sun is right on the celestial equator, so the Sun rises exactly east and sets exactly west. There are 12 hours of daylight and 12 hours of nighttime. Next slide. Now compare with the view from Fairbanks, much further north. The celestial equator is tipped over a lot more than in Los Angeles, so the equinox Sun takes a lower path, but it is still 12 hours of daylight and 12 hours of nighttime. Both this animation and the previous one for Los Angeles show the Sun reaches its highest point for the day when it crosses the meridian in the exact south. The meridian would be the arc going from the orange triangles on the horizon at north and south, and through the zenith diamond in the animations. Next slide. Now for the June solstice path, June 21st path, of the Sun. On the solstices, the Sun is 23.5 degrees north of, above, or south of, below, the celestial equator, which is the red dashed arc or circle in these animations. On all the days of spring and summer, the Sun follows a path between the celestial equator and the June 21st path, shown here. So the Sun rises in the northeast and sets in the northwest. Where it rises in the northeast and sets in the northwest depends on the particular day in the spring or summer. The side view shows very clearly that the Sun takes a full 24 hours to go around the Earth, but the fraction of its full 24-hour path that is above the horizon is greater than the part that is below the ground. For us in the northern hemisphere, there is more than 12 hours of daylight when the Sun is north of the celestial equator. Next slide. This animation is showing the December solstice path, December 21st path of the Sun. On all the days of fall and winter, the Sun follows a path south of the celestial equator, between the celestial equator and the December 21st path shown here. So the Sun rises in the southeast and sets in the southwest. Where it rises in the southeast and sets in the southwest depends on the particular day in the fall or winter. The Sun still takes a full 24 hours to go around the Earth. We have less than 12 hours of daylight because the fraction of its full 24-hour path that is above the horizon is less than the path that is below the ground. Next slide. Fairbanks, Alaska has a greater latitude since it is closer to the North Pole. As the latitude increases, the fraction of the June 21st sun's path visible above the horizon increases. Daylight is longer. That is because the farther north on the Earth you are, the more the sun's path is tipped, closer to being parallel to the horizon. Therefore, when the sun is north of the celestial equator, you can see more of its path above the horizon than if you were farther south, closer to the equator. Places north of the Arctic Circle, 66.5 degrees north latitude, can have 24 hours of daylight. Next slide. As the latitude increases, the fraction of the December 21st sun's path visible above the horizon decreases. Daylight is shorter. That's because the farther north on the Earth you are, the more the sun's path is tipped closer to being parallel to the horizon. Therefore, when the sun is south of the celestial equator, you can see less of its path above the horizon than if you were farther south. Places north of the Arctic Circle can have 24 hours of nighttime. Next slide. This slide shows how the sunrise position changes throughout the summer and fall. The first few hours of the sun's path is shown for Bakersfield. For this particular year, the autumnal equinox happened on September 23. In summer and spring, the sun rises in the northeast. In fall and winter, the sun rises in the southeast. The next picture shows the sunrise positions for the next 6 months, that is, throughout the winter and spring. Further down on the slide is the all-sky view showing the long, high path for the June solstice, the middle path for the equinox when the sun is right on the celestial equator, and the short, low path for the December solstice. Next slide. This slide first shows the view facing south to see the sun's path as it transits the meridian during the summer and fall seasons. You see that the fall paths are short and low, while the summer paths are long and high. For the particular year of these arcs, the autumnal equinox happened on September 22nd. The next picture shows the meridian crossings for the next 6 months, that is, throughout the winter and spring. The sun gets higher in the sky during the spring and summer months and is above the horizon for a longer time. So spring and summer are warmer than the fall and winter, when the sun stays low in the sky and is up for a shorter time. Further down on the slide is the all-sky view showing the long high path for the June solstice, the middle path for the equinox when the sun is right on the celestial equator, and the short low path for the December solstice. You can click on the link that says Go to Frames Version to bring up an alternate way to navigate through the different animations of the sun's motion at different times of the year in Los Angeles and in Fairbanks, Alaska.